All right, let's talk about something that's absolutely critical for any Java developer out there, Spring Security. It's the go-to framework for locking down your applications, and today we're going to break down exactly how it works.
Okay, so picture this. You've poured your heart and soul into building this amazing application. It works perfectly, it's slick, it's ready to go. But then that big question hits you. How do you actually protect it? How do you keep the wrong people out?
You know, the easiest way to wrap your head around Spring Security is to think of it like a digital bouncer for your app. Seriously, it stands right at the front door, it checks IDs, and it decides who gets in and where they're allowed to go once they're inside. It's your app's first and most important line of defense.
So, to get a little more formal, Spring Security is all about two fundamental jobs. First, there's authentication. That's all about proving you are who you say you are. Think of it like showing your ID at the door. And second, there's authorization. That's about what you're allowed to do once you're inside the club.
Okay, before we go any further, we've got to get the lingo down. We've already talked about authentication and authorization. Now, the principal, that's just a fancy word for the user who's currently logged in. And granted authority, that represents their permissions or their roles, like admin or user. It's what's on their VIP pass.
So, what's our bouncer doing all day? Well, every single time a request comes into your app, this chain of security filters grabs it. First, it authenticates the user, checks their ID. Then, it authorizes them, checks their permissions. If everything looks good, they're in. If not, access denied. It's that simple, and it happens automatically for every single request.
All right, let's zoom in on that very first step in the flow, the ID check. This is authentication, and it's all about figuring out who the user is.
Right, so before our bouncer can do anything, they need to know who's trying to get in. That means we need a way for people to sign up and log in. So how do we even start building that?
Well, it comes down to a few essential pieces of code. You're going to need a user entity to model your user, a repository to talk to your database, a controller to handle the web requests for registration, and a service layer to tie all the business logic together.
Okay, storing a username, simple enough. But a password? Whoa. This is one of the most critical security decisions you'll ever make as a developer. If you get this wrong, it's an absolute disaster waiting to happen.
And this right here, this shows you exactly why it's so important. On the left, you see a password stored in plain text. If a hacker gets into your database, it's game over. Every single account is compromised. But on the right, you see a securely hashed password. It's just a scrambled mess of characters that's basically useless to an attacker.
So, what's the solution? It's an algorithm called BCrypt, and it's the industry standard for a reason. It's a one-way street. You can't reverse the hash to get the original password. It also adds something called salt, which is just some random data, to every password before hashing. This means even if two people have the same password, their hashes will be completely different. And crucially, BCrypt is intentionally slow, which makes it a nightmare for attackers trying to guess passwords.
Okay, our user showed their ID, and it checks out. They're in the club. Now for part 2 of the bouncer's job, checking the VIP list to see where they're actually allowed to go. This is all about authorization.
But think about it. Just because you're in the club doesn't mean you can go everywhere, right? There's the VIP lounge, the manager's office. We need to control which parts of our application different users can access. And that, right there, is why roles are everything. An admin might need full power to create, update, and delete things. But a regular user, maybe they should only have read-only access. We use role-based access to enforce these rules.
So, let's actually look at what this looks like in the code. This first line tells Spring Security that any URL starting with /API/auth should be open to the public. Permit all means everyone gets in. This is perfect for things like your login and registration pages.
Now, what about the really sensitive stuff, the manager's office, right? Well, that's where this rule comes in. Hasrole admin puts a hard stop on any path under /API/admin. You must have the admin role to get past this point. No exceptions.
And then you have the general areas of the club, where most people can hang out. This rule, .has any role, user, admin, is a bit more flexible. It says that as long as you're a user or an admin, you're welcome to access these endpoints.
Okay, so think about this for a second. Making the user log in with a password for every single click would be a nightmare. It's slow, it's inefficient, we need a better way. So after they log in the first time, we give them a sort of temporary access badge they can just flash at the bouncer.
In the world of modern APIs, that badge is a JWT. A JWT, or JSON Web Token, is basically a small, secure string of text that contains user info. It's made of 3 parts: a header, a payload that carries things like the username and their roles, and a cryptographic signature. And that signature is the most important part. It's a digital seal that proves the token is legit and hasn't been messed with.
So the whole dance is actually pretty simple. The user logs in one time with their password. If it's correct, the server gives them back a JWT. The client, like your web browser or mobile app, saves that token. Then, for every single request after that, it just includes that token in the header. All the server has to do is check the token's signature, which is super fast, and boom, access granted. No need to hit the database every time.
Phew, okay, we've covered a lot of ground: authentication, authorization, hashing passwords, and using tokens. So let's pull this all together into one clear blueprint you can actually use to secure your application.
All right, quick lightning round recap. Spring Security is the whole framework. Authentication is about who you are. Authorization is about what you can do. BCrypt is how we keep passwords safe. Role-based access is how we enforce the rules. And JWT is the modern, efficient way to handle it all in stateless APIs. And hey, one last pro tip before we wrap up. To make all of this manageable, especially as your app grows, a clean project structure is going to be your best friend. Separating your code into packages like this for config, controllers, entities, and services will save you so many headaches down the line.
So there you have it. We've gone through the entire blueprint, from the front door ID check all the way to the VIP list. You've got the concepts, you've got the tools. The only thing left to ask is, what are you going to secure first?